Sorry, I had to fix my background. Hello and good afternoon from this part of the world. This is a very heartfelt welcome to all of us. All of our interns have been quite excited about this day, and it's interesting to know that the day for the open source project presentation has finally come, and we have renowned members of the industry here with us. So, Bob, before we go ahead to the presentation proper, there are a couple of things that we just like to uh, get to see with ourselves. So, with all of the enthusiasm coming with the end of the year and the end of the internship, I think it's also important that we get to ask ourselves how has been, working in a team. How has the interaction on Slack and trying to get our presentation proper ready, and how has it been collaboration generally? So I'd like to invite one of us who would give us a 1 minute feedback. She's actually excited about this day as well, and she's excited about giving us a feedback. So Sharon Ibeji is one of our interns and an active member of her group uh, doing a particular project. So Sharon Ibeji will be giving us a few feedbacks about how the experience has been working in a team.
Good
So
afternoon.
meanwhile, yes, good afternoon, Sharon. How has it been working in a team in the open source project so far?
Well, it's been good because there's this thing about working in a team whereby most times team members are not cooperating, but this time around the experience was different. It was I felt the cooperation, I felt the interest of people, I felt the commitment, and I wasn't in a position of running around to meet people. I wasn't in a position of letting all work to myself, but I had the opportunity to learn from different people with different ideas, different approaches to work. So I really, really enjoyed it, and it helped my data science growth a lot. Thank you.
Thank you so much, Sharon. So if you would get another chance, would you grab it with all your heart?
Yeah, I would actually. I would because this experience was good. I will.
So thank you so much, Sharon. I know a lot of us still have our comments, so we can put it in the chat box, and then we'll see. So long you have enjoyed this program, let us know in the chat box, and it will be taken note of. So we continue with the open source project presentation, and I'll leave you in the hands of our very own Tobiloba at Digimo, who will handle proceedings from here. Thank you, guys.
Thank you, Emmanuel. Hello, everyone. Welcome to Amway Open Source presentation. I'm sure everyone is excited today. Now, the presentations today will last for an hour and 15 minutes. Now, we have 15 groups. All groups are expected to present within 5 minutes, and we hope everybody can get to present today. And if that doesn't happen, we'll take this some other time. Also, remember that there is a juicy prize for the winning group. All the groups will be having 3 judges, and our judging criteria will be based on the quality of solution, methodology, and the quality of your presentation. After each presentation, you will get questions from our judges, if there are any, and also get feedback from the judges at the end of the presentation. So let me introduce our first judge, Charles Adetiloye. Charles is the co-founder of Maven Code. He has over a decade worth of experience consulting and implementing large-scale distributed data processing software platforms. Wale Akinfadering is the second judge for today's presentation. He's a data scientist for Amazon Web Services, a Google developer expert for machine learning, and in his spare time, he conducts research on machine learning for the developing world. Now to our third judge, Biodun Awojobi. Now, Biodun is a customer engineer for Google. He is a creative technology architect, cloud security leader, and an accomplished scholar with strengths in business strategy and computing. You've listened to our astute and excellent judges lecture before, their mannerism, their eloquence, and their skill. Now it's your turn to be heard. The next voice you'll be hearing now will be that of the first group, Road Safety, and the speakers, Kenichi Ojuku and Uthman Tijani. Kenichi Ojuku, you can go now.
Okay, good day everyone. My name is Kenichi.
Yeah, good energy.
Sorry,
You
can
can
you
share
hear
your
me?
screen. Yeah, I can.
All right. Okay.
You have 5 minutes to present.
All right. Can you all see my screen?
No, I can't see your
Not yet from
screen.
the start.
Okay, sorry. All right, can you all see my screen now?
Yeah, I
Oh,
can.
yeah.
All right. Thank you. All right. Good day, everyone. Good day to our panel of judges. My name is Kenichi Ojukwu, and I'm from the Data Engineering track. Today, I'll be presenting an open source project titled Analysis on Traffic Accidents in the UK using the UK 2016 Road Safety Model. For our team, we had Gloria Alabi as the project lead, Manti Jani as the query analyst, and other hardworking developers whose names are listed. In this project, we'll be analyzing the 9th leading cause of death globally, taking 1 million plus lives yearly, and on average, 30,000 plus lives daily. The current solutions to the problem are road signs and traffic lights, sidewalks and curbs, emergency lanes, road speed limits. In this project, we'll use data science and machine learning techniques to determine the factors responsible for road accidents. We built a predictive model that can tell the severity of accidents based on certain factors, that is features. We gave recommendations on how road safety policies can better reduce and prevent road accidents. The data set is sourced from the UK Department of Transport. There are four CSVs in this. There are four CSV used as data sets: the casualty data, the make and model details involve the accidents, the lookup tables for variables, vehicle data, and the main data set containing the accident data. The workflow in preparing the data for prediction are transformation. Here, we extracted the year and month. For time, we extracted the hour of the day. We dropped all missing values, encoded the categorical features, and then we proceeded to visualize the data. During analysis, that the accident rate increased during the month of November and dropped really low during the month of February. Personally, I attribute this high death rates in the month of November to the durations of the festive period in December. For cyclists, it is seen that the majority of the accidents occur in the urban area as compared to the small towns and rural areas. The affected age of drivers fall within the age of 20 to 50 years, which tend to be normal since the older citizens won't be in perfect condition. On the good side, approximately 83% of the accidents are mild with no casualties. From the data set, drivers have approximately 68% chance of coming out injured during accidents. As said earlier, we cleaned up the data by dropping missing values and performed feature transformation. We split the data at a 30 ratio. 70% of the data was used in training and 30% for testing. And then a pipeline was built for the best. 4 different models were tested: the random forest classifier, the XGBoost classifier, the LGBM classifier, the light gradient boost, and extra trace classifier. Here, random forest had the highest accuracy of 84.7%. It was imbalanced. We performed upsampling techniques for the lesser class and removed highly correlated features. Here, XGBoost had the highest accuracy of 88%. From this data set or analysis of the data set, cars are at a high chance of being victims in serious accidents. Majority of the recorded accidents are mild with almost zero casualty. The month of November accounts for most. This gives the government the opportunity to emphasize more on preventive measures during this period. And with a balanced data set, the XGBoost classifier is the best performing model with an accuracy of 88%. Thank you.
Thank you, Kenichi. Now over to our judges.
Yeah, quick question. So you said during November, December, there's a lot of, roadside accident, probably due to festivity and things like that. Do you think it's mostly due to that, or probably due to the weather change? Around that time, there's a lot of, it's during the winter where people find it difficult to drive properly. So I think it runs from like November to like around early March. So do you think there's a correlation due to the weather or any external factor, and not necessarily due to festivities like you I posted theorized or something like that?
Okay, yes, we bring that into consideration. I believe that weather might also play parts in the increase in accidents or death rates, coupled with the fact that everyone is also trying to get ready for the festive period in December.
Okay. All right.
Yeah. Just a sort of a continuation with to what Charles asked. What did you do with the timestamp? Did you use it?
Yeah. Yes, we used it. We used month and year. Then we used the hour of the day in the data set.
Okay.
For prediction.
And then the other question is that there's a huge imbalance in your data set. So I was wondering why you guys presented only the accuracy and not other metrics.
We noticed while during the training period, we noticed that the F1 score and the accuracy were the same. So assuming we had accuracy 8%, we also had an F1 score of 0.88.
Okay, all right, sure, thanks.
Yeah, nothing from me for now.
Yeah. Let me ask one more question, Dan. So in terms of the model selection, how many training iterations did you go through before you concluded that model A is better than model B, and you finally settled on the XGBoost model as the best performer? How many training iterations did you guys do?
That I do not have an answer to, because I wasn't in the data. I wasn't the person that built the model pipeline. But I think we concluded, but from what I can see, I think that we used the highest accuracy for, as a determining factor of what model we're going to use.
Yeah. Well, because before you get to that stage, you probably went through several iterations, tuned your hyperparameters, and you now concluded like, okay, we're getting the best out of XGBoost. I just want to know how many iterations you guys went through before you did that selection. Is the person that did that on the team right now, or are you the only one?
Yeah, it's Tijani Utman. Yeah, I think I'm not sure if Tijani Utman is around currently, but yes, he's the one
around.
that handled the data science part.
Okay, I just want to know.
All right, thank you, Kenichi. Uthman, if you have anything to say, you are a co-host, you can speak now.
Yeah, I'll just drop the message in the chat.
All right, thank you. Now, moving on to the next group. For the next presentation, we have group, let me see, we have group 14, suicide cases, and we have Oladapo Joseph and Odeshino Abdulkodri. So you can present now. Oladapo Joseph, you are a co-host.
Good afternoon, everybody. My name is Adeleke Oladapo Joseph. Can you hear me?
Yep.
All right. I'm representing Group 14, and the title of the project is Suicide Cases Around the World. Sorry. Here's a list of my team members. The first task of this project requires us to show the percentage increase in suicide across the decades for each gender, male and female, and age groups. The big part of it is for us to deduce reasons for answers in our findings above. Second task that we gave ourselves is to find the years with the highest suicide rate for each gender and age group, and also deduce reasons that are responsible for the factors above. So. And lastly, to find out if population is actually correlated with suicide rates in each country. The data set we are given was gotten from WHO, the World Health Organization. It's a collection of suicide recorded from all the way from 1979 up to 2016, from about 141 different countries. It contains the record of both the male and female gender at different age groups for each year in different countries. The quality of data, however, is quite poor according to WHO. That about just 80 member states have good quality data that can be used to predict or estimate the suicide rate. Our approach to this was about 12.8% of this population data are missing values. So we used backward fill method to fill the missing values. Different tasks that we had different goals. So we use different pre-processing methods depending on the factor and the task given to evaluate our end goal. So we believe the graphical representation of what we got is better than just values. So we express our findings graphically. The first task, which was to show the percentage increase in suicide rate across decades. From 1979 to 2016, there are 5 decades there. As you can see from data set from the graph, the first decade was when data got recorded at 0%, but second decade we had about 1,865% increase in the suicide rate recorded worldwide for the male, and the female is shown in green here, in orange. Yes, sir. The third decade had 45% increase for the male and about 19% increase for the female all over the world. In the fourth decade, we had 6.7% increment in the suicide rates all over the world for the male, and just a little 0.89% increase for the female in the fourth decade, which is from 1999 to 2009. The last decade, which we are discussing, is from 2009 up to 2016. The reasons we deduce for this could be we had the highest increase in the second decade, but we felt probably because data collection started from 1979, probably there was poor collection of data. So the second decade could not be used as a basis. So the third decade, which is from 1989 to 1998, we had 45.717 increments in total for male, and 19.39 for the female. These may be reasons with these were probably because of the war. There were so many pandemics in the previous decade. There were so many wars in that same decade. That could be reasons leading to suicide. In the male, according to our graph, the male gender had more suicide cases. Reasons could be because of war. In 1990, we had the third and fourth revolution, which could have resulted into job loss and other also factors that we consider responsible for high increments in the suicide rate. We can also see from the fourth decade to the fifth decade, there was a sharp decrease, minus 44%. that shows that people had started adjusting to the new life. Probably they are started adjusting to the new life of the computer age and everything, getting used to the new life. The second task, to show the suicide per year with respect to sex or gender. Turn out to add the highest suicide recorded for the male. And in 1999, add the highest for the female. This same thing was discussed in the previous slide, that same decade. Thirdly, to show the correlation between suicide and population over the years. We can see that here, it shows suicide is highly correlated with population, meaning the higher the population, we have the higher the suicide rate. Towards the end of the decade, towards the end of the graph, towards our right, we see a very light purple, indicating up to 0.7 in correlation. Right, all over across all the years, from the 1979 to 2016, we see here that is about 0.61. Data overview. This shows the amount of suicide cases for both genders, the male and the female, across the 5 decades. Sorry, and also for the age groups, different age groups that we had. 35 years to 54 years had more suicide cases. These are the ages where people are probably getting sacked or something. In summary, we have more more male suicides. About 76.3% of total suicide cases recorded were male, why we are just 3.7% female. Women.
Thank you, Ladako.
So
You're past time already, but you can keep talking. 10 seconds.
Okay. Globally, we are witnessing a downward trend in the suicide rates all over the world, which is a good thing for us. So lastly, I'll say no to suicide. Thank you.
Thank you, Ladako. Now to the judges.
Yeah, just to say something that I picked up when you were talking. So the higher the population, the higher the suicide rate. I think, and that's true. But you don't want to base it on that. You want to normalize it and say, what is the total suicide rate per maybe for every 1,000 people? So you need to normalize it across a smaller population sample and a larger population sample. So if you do that, you find out like the suicide rate per, let's say, 1 million people or 1,000 people in a larger population may be smaller than the suicide rate for a smaller population, right?
Okay.
Because you have a larger data set, so it's more likely for you to have a higher suicide rate, but you need to like normalize it so that you can compare with like countries like a lower population.
Okay, so
right. Then can you explain the reason why the graph, I mean, were there any indicators or any main explanation looking at the graph over the decades? And the way you labeled it was a little bit confusing, like decade 1, decade 2, decade 3. Why not just use like the beginning of the century, like 1980, 1990, 2000? You want to fix that if you can in your subsequent presentations. So I mean, if someone picks this up like without knowing the context, they won't know what decade 1, decade 2, and decade 3 is. So, but what I'm trying to get to with that is like, do you have a solid explanation why there was a drop in suicide rate towards in the last decade? Is it because of a lot more awareness, people are getting a lot more comfortable, or there's not been any major war in this decade?
Yeah.
And what are the major contributing factors to suicide rates, if you can, from the data set you saw?
What can I say about the major decrease in suicide rate all over the world?
Exactly. Yeah. Do you think any
people are getting the increase? I think the increase in standard of living is also a factor to consider. There is improved standard of living across board everywhere, improved healthcare system and everything. In the 1970s, there were like serious pandemics and serious. We had influenza. We had a couple of other things that could have resulted into high suicide rates, and civil wars were like at their peak in the 1980s. The civil war in Nigeria, civil war in all over the world, across board. So I think one of the reasons that could also have led to the high increase in suicide rate between 1990 to 2000 could be the civil war, the pandemic, and loss of jobs. The revolution, like I said, third and fourth revolution happened from 1970 up to 1990. A lot of people lost their jobs, and in the 2000, the last decade that was considered, people had started learning the skills required. That's what I feel. People started learning the skills required to adapt to the new revolution.
Yeah, I mean, I'm not very convinced about that, but I mean, some of what you're saying is true, but I mean, there are a lot more external factors, probably a lot more awareness. People talk about it a lot more right now. So people are likely to get help if they're trying to go that route. But I think a few years ago, most people won't talk about this. There wasn't any social safety net to help people out. So we don't know, but I was thinking maybe we can find out that from the data. Well, I mean, great stuff, man. Yeah.
Okay.
That's it from me. Yeah.
Yeah, so I'll add a little bit more context to what Charles has mentioned. I think you have a lot of data set, and with your data set, what I would have loved to see, and this is not feedback yet, is are you able to predict with, and does your prediction match what's happening in current terms? The whole point of having a large data set is to be able to make predictions and see how those predictions match, or make predictions in the next 10 years. So say, for example, all things being equal, nothing changes. What do you expect? And how does your prediction match what has happened in the past, if that makes sense? But yeah, overall, I think it was a good presentation.
Okay, so noted, I'll noted this.
Yeah, I have nothing for now. I'll probably give feedback after the presentations.
All right. Thank you, Oladapo. Now moving to the next group. Please remember that you have 5 minutes to present. So the next group, group 9, water salinity, Edeba, Jerry Efemena, and Justus Bayo. You can present now.
Hello guys, can you hear me?
Yes, we can.
Okay.
Can you share your screen?
Yeah, I'm about to do that. Okay. Can you see my screen now?
Yeah.
We can see it.
Okay, so hello all. My name is Efemena. I am a member of Group 9, the Water Salinity Project. I was opportunity to work with really some amazing guys from data science, data storytelling, and engineering track. It was great working with them all. Our project focused on a major problem that is affecting the world in general, and that is the climate change. These climate change issues affect both humans as well as it does aquatic life. And that is why our project seeks to address the issue of water salinity, that is the level of saltiness of the sea. We focused on being able to determine what is the increase, or whether there's any increase or decrease in this level of salinity, and what factors might be contributing to it. Our data set was collected by California Cooperative Oceanic Fishery Investigations. It contains data from 1949 to 2016, and it was collected from more than 50,000 sampling stations. It contains both the physical property, chemicals property, and biological property of the sea. And we decided to approach this problem through the exploratory data analysis. Then we did data visualization, after which we did our data preprocessing, modeling, and deployment. During the exploratory data analysis phase, it showed us that we were working with a very large data set that had about 864,863 rows with 74 columns. Consist of only 3 data types: float 64, integer 64, and object as well. During the data visualization phase, it also showed to us that as large as our data set is, not every feature in the column are necessary for the prediction of water salinity. Temperature, for example, is one of the features that was very necessary because it shows a linear relationship with salinity. And as a result of that, we took it into cognizance when doing our prediction. This is also our heat map to determine the multicollinearity of all the properties in the columns that we made use of. And then we were also able to discover that our data, most of them are skewed. And as such, we needed to do something about it. And that is what you can see on the distribution chart here. So as such, during the processing phase, we had to rename the columns because most of the columns were not properly named and they were not easily readable. We renamed them. And then we had so much missing data. As a result of that, we had to drop missing data that had 70% missing values. The remaining data, we use main imputation to fill them. The categorical features were also separated from the numerical features because it was clear to us that only the numerical features would be needed for the prediction of the salinity of the sea. And because of the squareness of the data, we had to do both normalization and standardization of the features that we intended to use for our prediction. Having done the pre-processing, it was clear to us that the following columns reported specific volume anomaly column, the temperature column, the oxygen saturation column, the depth column, and the pressure column had higher influences or greater influences on our model. That was why we now decided to try various prediction models. We had to do the linear regression. We had to also do decision tree regressor, SGBoost regressor, LGBM regressor, CATBoost regressor modeling. And after doing that in all, the SGBoost regressors had the best performance with the R02 square score of 0.9917. And as a result of that, we took that into cognizance when building our pipeline. The Prophet was also used for our time series analysis. We were able to discover during the time series analysis that there has been an increase over time of the level of salinity of the sea. It also shows on a yearly basis that, if you can see from the graph there, on the yearly basis that July has the lowest point. Though we were not able to confirm this, but because of the relationship between temperature and salinity, we take into cognizance the fact that July is the hottest month in California. And so that probably is part of the reason why July has the lowest point in the yearly forecast. And also on the weekly basis, we also discovered that Friday too has the lowest point. In training our model for the pipeline, we decided to use the Keras API on TensorFlow Deep Learning API. And each of the components of this pipeline was built separately: the data preprocessing, the prediction, and the training. But we are unable to get a graphical representation of the running pipeline because of the fact that only the GCP free tier was available to us. But the components for these models are available on the model folder in our GitHub repo for you to take a look at. So finally, only a few features, we are able to discover that only a few features from our large data set is needed to predict water salinity accurately. And the time series also shows that there's an increase over time. And as such, there is need to give attention to aquatic life that cannot adapt to change in salinity to avoid extinction, because there are some aquatic life that can do that, but those that cannot do that, we recommend that they need to preserve them in a well-controlled environment so that these ones will be able to adapt with time. Thank you very much.
Yeah, thank you, Edeba. Now over to our judges.
Yeah, thanks for this wonderful presentation. You mentioned that you guys removed categorical features. So I was wondering why you just left it out.
Yeah, we had to use most of the futures based on the salinity that we want to predict. Most of the futures that show correlation with salinity, the column that we want to predict, none of them were from the categorical futures. And for the fact that we had a very large data set, importing the data set into our code lab and Colab and other editors that we use, we had to slice our data so that we can be able to import them and make use of them.
Yes, but the problem with doing a correlation map is that you want continuous variables on both sides, right? But this is categorical features, and they should probably be treated differently. So I was wondering, maybe there might be some signal that you guys would miss from taking out the categorical features. But nonetheless, it's a wonderful presentation. Thank you.
Thank you.
Yeah, I think I agree with you on that. So just to key in on that, you never consider doing any principal component analysis to know like, okay, this is a derived value, we don't need it. Because the danger is like you guys trying to like just drop a column without knowing that this thing has a correlation with something. Is it just by observation or just like, we don't need it, let's drop it?
No, we first of all made use of all the data to run the correlation to be sure that those data do not show high correlation with salinity before we drop them.
Okay. Okay. Cool. Then the other thing is I saw that caught my attention was like when you were showing the data structure, the columns and the rows and everything. You have an object data type with just 4 elements, or I mean, how many object data type did you have?
Our object data type was four object data types.
Yeah, that was
specified. 4. That's what's there. 4.
Yeah. So
you can see it there.
Yeah.
We had object 4, integer 64, 5, and float 65.
Okay. And what kind of object data type do you have again? When you say it's an object data type, what kind of objects are those? Hello?
Oh, I cannot really remember right now.
Okay. And there was no string data type, just floats and integers alone? Or quantitative values?
No, there was no string data types.
Oh. All right. Yeah, I'll just follow up with you to check the schema and see what those are. I'm just a little bit curious. I mean, no string, no nothing, just float and integer?
Yes, that's just what we had.
Okay, all right, no problem. Cool, good stuff.
Yeah, one more thought. Good presentation overall, but if you go to the next slide, your heat map. No, actually, it is your heat map. Where you show the heat map. What are you really trying to show, if you don't mind me asking? Like, what does the heat map represent to you? I mean, by looking at this,
the heat map was to show the core.
Yeah, by looking at this, like, what have you derived exactly?
Okay, the heat map was to show the correlation between all the data sets that were the other columns that we had on our data set. And you see the scale. The scale is by the side to show which is highly correlated and which is not.
Okay, so what are the learnings?
From 0.75.
Yeah, so what did you learn from this heat map? Like if you were to present it to your manager, what would you say you've learned from this heat map?
Okay, from the heat map, that was where we were able to determine the futures that I made mention of earlier that are highly correlated with, that have show high correlation with the column that we are trying to predict. And those columns are the reported specific volume anomaly, temperature, oxygen saturation, depth, and pressure. So in explaining to my manager, I will let him know that these are the futures that we need to pay more attention for. If need be, collect more samples specifically on these futures so that we can try use these futures to predict more accurately the salinity of the sea.
Okay. All right. Well, yeah, the other thing I want to call out is use determine, not determine. We use it a lot. Use determine, not determine. All right.
Thank you very much for that. I missed it.
Yeah, thank you. Now over to the next speaker, the next group, that's group 18, crime unemployment, Ome Chukwuemeka and Miracle Sigwe.
We are three asking questions, so there are three no's.
Ome Chukwuemeka and Osigwe. Okay, you're a co-host now. Can you share your screen?
Hi everyone. Good afternoon.
Hi, Miracle.
This is Miracle. A moment, please. Okay. I hope you can see my screen.
It's still loading here. I can now.
This is group 18, crime unemployment, and we're trying to present findings, and the team members are as listed here, the team lead, as well as the data query analyst, and as well as my colleagues who did a wonderful job to get this across to us. I don't know if you can hear me clearly.
Yes, we can.
Yeah, bro, you can pump up the volume a little bit if you can.
Okay. How about now? I don't know, is it clear enough? Is it audible?
Yeah, it's a little bit better.
Okay. So quickly looking at the data description, we discovered that the diversity of life is though with implication of having criminal networks around whereby they to decide to seek a job. So our project is trying to learn unemployment. Is it that people tend to venture into crime when they are unemployed, or is it the reverse that is the case? So looking at our project statement, sometimes there tends to be a surge in crime in a country that has a spike in unemployment rate. So, and then some other things we're trying to look at, which is there a strong correlation between crime rates and unemployment in a given society? Then I'm looking at the importance of data and ascertaining if there's any relationship, if there's anything that can point to crime due to having people unemployed in a society. So, but this project tends to address this by using US as a case study. So the question actually is, will a rise or decline in unemployment cause a corresponding rise or decline in the number of violent crimes reported? So, and then the existing solution we have is that most of them are non-data, it's just non-data in the sense that there's no, when we did our research, there was no data telling us, okay, there's any relationship, either negatively or positively. So most of the existing solutions are non-data or other unethical driven solutions and approach. So before now, crime rates and employment rates have been studied by merely looking at populations in a given geographical setting. And then our approach is we actually use the normal approach. We start with data wrangling, renaming the state column, which is abbreviated into full state name. We actually explore the data sets using Python libraries like Pandas, NumPy, Seaborn, and Matplotlib to explore hidden features in the data set. And then we did some data modeling, which is trying to identify any correlation between violent crimes and unemployment in the 51 United States. And then we checked the workflow pipeline building. Though actually this project didn't actually venture into building or testing a model on something, just try to draw any visual correlation between unemployment and crimes. So the project description, we have the data set containing data on various crimes like murder, rape, robbery, aggravated assault, burglary rather, larceny, theft, and vehicle theft. Sorry about that pronunciation. So collected over a period of 39 years from 1976 to 2014 across all 51 states in the United States, and consists of 1,989 rows and 14 columns. The state column was in abbreviated form, which was later renamed to full state name in USA. So the data exploration showed that there's a relatively weak correlation with various crime across the 51 states of the United States. And then the project workflow started from data wrangling down to data processing, data analysis, and then data modeling and piping, the validation conclusion, and then we checked to verify if our conclusion actually tally with what the data is saying. And so this is just continuation of what I just said the other time. And then the modeling, this project does not explicitly involve developing any machine learning model, but a predictive, prescriptive, or descriptive model. It's basically using data to draw inference or insights on correlation between violent crime and unemployment rate in the United States. So, moving straight to what we have here, we discover after our analysis that 19% correlation exists between violent crimes, that is the violent total crimes, and unemployment, using this scatter plot that we have here. And then also further discover, that each of these crime, like from murder to robbery to rape to aggravated assault, each have its own correlation with unemployment. Like for instance, aggravated assault has a 14% correlation. Murder had 22% correlation with unemployment. Robbery had 21% correlation with unemployment, as well as rape having 6% correlation with unemployment. So we used an area plot to try and identify which of these states, after taking the sum of the various violent crime, which of these states tends to sway, that is trying to point to us if there's any correlation with unemployment and then crime. And then from this plot, we discovered that Connecticut has very high, violent total crimes in the state, almost close to the top of the plot. So this on its own is telling us that even if we want to analyze this on various angles, it is very, very important to understand if a state having high unemployment rate is actually going to make people venture into crimes. Then looking at the unemployment plot on this side, we discover that even the Connecticut that has a high violent total crimes is not having an equal amount of relationship between the both of them. So our further findings discover that for the year 1989, the West Virginia, which is the state with the highest unemployment rate, does not appear in the top 10 states.
Miracle, your time is up. Please wrap up.
Okay.
10 seconds, please.
Okay, so just the summary of what I'm trying to say is that the detailed exploration of the data set shows very weak correlation between unemployment and violent crime. So we can conclude that the rise or decline in unemployment does not cause a rise or decline in violent crimes. Thank you very much.
Thank you, Miracle. Over to our judges now.
Go ahead. I'll go.
Just real quick. Can you go to slide 15? Actually, what the y-axis? What numbers are those?
That's the total number of crimes that is committed. Combination of the murder, combination of the aggravated assault and rape, alongside with the last one. Those are the four. Those
I
are the
couldn't
four.
hear. So I'm asking, is there a unit for that? So because you said area plots, I don't know if it's in some square meters or if it's like the number of.
Yes, it's the number, the total number of crime.
And then for the unemployment, those are percentages, right?
Yes, those are percentage.
Okay. All right.
So again, what I want to say is, I mean, if you look at this data and you don't know anything about all the states, you think it's right, but in reality, Connecticut is one of the safest states in the U.S. I mean, the crime rate per capita is less than most states. So there's something wrong with this data or the way you've presented or interpreted it that we don't really know, because when you're trying to do all these things, the question is like, did you normalize it? So like, what's the crime rate per maybe 1,000 people or per maybe 10,000 people? So the fact that your data is showing that Connecticut is pretty high in crime rate, I don't think that's true. So you might want to look at what you did out there. And things like that. And in terms of unemployment as well, Connecticut, um, I mean, if you're talking about city that are not like with a low high unemployment, I don't think it's going to be part of them. It's probably going to be uh, states like Alabama, Mississippi, and things like that, which are not showing up in this graph. So for someone who understands all these things in real life, your data doesn't correlate with what's on ground. So can you explain why that's the case, or why there's that kind of inconsistency in terms of what you're trying to do?
Okay, the data set we used actually was sorry, period of just give me a minute. So we used from 1976 to 2014. So
Yeah,
I think that's
even
what
with that, Connecticut should not be that high. I mean,
Yeah.
it just stands out compared to like other states where they're like, if you're showing Illinois, Chicago, it's probably correct. But I mean, we'll probably need to look into that data the way you like came to this conclusion. Connecticut is not as high as this, I would say, just from observation and knowing what's happening out there and a little bit about this place. So compared to other places, relatively, I don't think it is as high as what you're saying.
okay.
Yeah, it's plus one to what Charles has mentioned. I mean, if for violent crime, I wouldn't expect to see Connecticut on there.
Yeah.
My assumption would be maybe you have data that's more heavily weighted to Connecticut and lightly weighted to other parts of America.
Exactly.
Yeah, it doesn't seem accurate. Yeah, Chicago, New York, you expect to see more crimes in those places. Population in Connecticut is significantly smaller as well. So
Yeah.
Also, looking at this slide, that says that the state of Utah, which have high unemployment rates. Nah, Utah doesn't have high unemployment rates.
No, it doesn't. Yep.
Okay, thank you. Thank you. So we'll move on to the next presenter for Group 11 Financial Products, and that will be Emmanuel Ogunwede and Oladipo Ibenwu. So Emmanuel and Oladipo.
All right, good afternoon.
Good afternoon,
Let me
Emmanuel.
share my screen. All right, can you see my screen?
Yes, we can. Yes, we can.
Yep.
All right. Oops, sorry. All right, good afternoon. My name is Emmanuel Gomez, and I'll be presenting on behalf of Group 11. We worked on the financial product data. I worked alongside some really amazing teammates. And all right, let's get to it. So when you think about products from a business perspective, one of the first things that comes to mind is customers. And more importantly, if the business model of a particular product is revolving around its customers, then we know that the success of that product in the market largely depends on the satisfaction of the customers. And in such situations, we already know that two things becomes the goal for such products. How do we maximize retention and how do we minimize churn? And research has shown that one of the top 5 reasons for churn is actually poor customer service. In fact, according to MasterCard Insights, churn has a lot more to do with field quality and service than it has to do with increase in price. And research has also shown, according to Talify.com, that minimizing churn by a mere 5% can lead to up to 25 to 125% increase in profits. And so that simply tells us that keeping a customer happy for such products is very important. Now, when a customer is unhappy and he's complaining about the product, two things are involved. How well are we responding to these customers and how fast are we responding to these customers? And so from our data sets, we realized that inadequate responses and slow response time are issues that directly affect consumers' overall experience and satisfaction. And so the goal for us was to kind of find a way to maximize a customer's satisfaction, because we know that customers who are already complaining about a product have higher tendency to churn on that product. And we also try to see how we can reduce response time. Now, Cognizant actually carried out a research, and then they found out that by applying machine learning algorithms to customer care data, they realized that they were able to arm customer care agents with the ability to troubleshoot and resolve customer challenges proactively. And the angle we're coming from now is we're not just trying to optimize what's happening in the customer care center, we're also trying to reduce the effort a particular customer has to put into getting himself hired and making a complaint for a particular product. Now, this is from our data sets, and here what we are seeing is the average response time across different products in our data sets. And I'm bringing this up because, if we think about financial products, here we can see that we have about, like the highest here is 8 days average response time for issues related to credit reporting. And then we have about 2 days response time for issue relating to student loan. But then let's be realistic. If someone was stranded somewhere and I'm trying to send money to the person, and then, my bank is telling me that, hey, it's going to take an average of 2 days to respond to your complaint, that's really not realistic for a financial product. That can be really, really detrimental. And our approach to this problem was basically, we carried out an extensive research to determine how to efficiently prepare data for the choosing issues we wanted to address. That's how can we reduce the churn rate, how can we maximize retention, from the angle that if we can help customers who are already having dissatisfaction, make less efforts to becoming hard, and then we can optimize the amount of time they put into making complaints, then we can actually help them enjoy that product and reduce the chances of them churning. And so we also selected candidate algorithms to serve as model of choice in carrying out multi-class classification, because what we're trying to do here is we're trying to predict if what category a particular complaint fell under. And I would explain why as we proceed. Research on candidate performance metrics to measure selected models and tune developed models of these algorithms to was taken into consideration. Now, we use the US Consumer Financial Protection Bureau data. They actually provided a data set, and that data set contained a column where a customer actually narrated the problem he was having, and then we had columns where we saw what day the customer made that complaint and what day it was forwarded to them. And the data set contained about 555,000 records, and only 68,000 of these records had the customer complaints field not null or not empty. And basically, we just focused on 2 features here. Our target feature was the product, and then our input vector just consisted of this complaint from a particular customer. And so we built a bunch of models. We actually explored both machine learning and deep learning techniques, but then we quickly realized that if we consider the idea of model parsimony, then it will be better to settle for like simple models that was explaining what was happening. And this is basically because those simple models were giving us very similar accuracy to the deep learning techniques on this particular data set. Most pre-trained word embeddings too could not represent like the data set very well. And so our model had an accuracy of approximately 83% on the test data and a similar F1 score of approximately 83% on the test data. Our biggest challenge with this data set was the heavy imbalance after we cleared out the null fields. So as you can see from here, there are certain products that have like a lot of complaints present, and then there are certain products that are heavily underrepresented. And since we decided that both that every product is equally important, we decided to actually track the F1 score, and we also agreed that both precision and recall was equally important for our particular problem. And so the first thing we explored were logistic regression models, tuning different hyperparameters. And this was meant to be our baseline, but we eventually went forward with it because the performance we got after seriously exploring logistic regression was very similar to what we're getting on other models. And then we realized that tree-based models was actually very slow in training during the training process. And so the model we selected was the logistic regression model using cross-validation, because it gave us fairly similar and high precision and recall, and then it was very similar to our F1 score. Now, the whole idea of the project—
Your time is up, Emmanuel.
Okay,
so use 10 seconds.
All right, so by reducing the amount of time and effort required by a customer to get them heard, we believe that we're able to improve their overall experience, and automating the flow of complaints categorization and removing human intervention can greatly influence the speed at which complaints are attended to.
Yes, thank you very much. Thank you very much, Manuel. Judges.
You actually mentioned, thanks for the presentation. You mentioned that you guys used embeddings and you didn't get good results.
Yes, we did.
So you feed in your word embeddings into what model? Traditional machine.
Sir?
Did you use traditional machine?
Yes, we fed in the word embeddings into deep learning models.
And results were terrible.
The accuracy and F1 scores were very similar to our logistic regression. I think GLOVE, the one with 6 billion tokens, was only representing about 52% of our tokens. And then the one with about 42 billion tokens was only representing 72% of our tokens after we encoded with TF-IDF. So,
oh, okay, you were using the pre-trained embeddings. So I was wondering if training the embeddings on the financial data itself.
Yeah, I did that also. We did that also, and we noticed something that was a little bit bizarre. The loss for the validation set was continuously increasing, and that was basically a problem. So to just avoid complexity, we just decided to settle for fractional ML.
Yeah. Okay. Okay. Thank you.
Yeah. One more question. So you had mentioned that there were like customer complaints, like there was a column for customer complaints in your data set. Is that correct?
Yes, that's correct.
Mm-hmm. So what did you do with that data set? Did you take all of that? How did you analyze that section?
All right, so what we did was we first of all eliminated the null columns because we knew that they would be useless to a particular problem. And then we explored using bag of word models and TF-IDF vectorizers. Bag of word generally for different grams performed poorly on the data sets when we use traditional models. And then TF-IDF was given like really high and better performance compared to bag of word models. And so we settled for the TF-IDF vectorizer.
Okay. And what was your biggest learning from what you got from when you analyzed it with the TF-ID?
Okay, with TF-IDF, we had about 83% accuracy and similar F1 score on the test data set.
Yeah, beyond that, like, is there like a current, is there like a trend in what customers are saying?
No, I didn't explore that actually.
Okay. And yeah, we'll get to this during the feedback.
All right, thank you.
Just to key in on what you said you did with CFIDF, did you remove any stop words?
Yes, we did remove stop words, and what was interesting in the data set was that removing the stop words did not actually change the performance compared to when we did not remove the stop words.
Why? Any reason for that? Not too much stop words? Or?
I actually did not explore that in detail, but that was basically what I noticed, and so I just decided to go with, for the traditional model, decided to go without removing the stop words.
Okay, all right, cool, thank you.
Thank you.
Okay, thank you, Emmanuel. Move on to the next group for the presentation. That's group 20, restaurant sales. And the presenters are Oluwasayo Akinkunmi and Okpeyemi Ajala.
Hello. Good afternoon, everyone.
Yes, good afternoon. Welcome.
Let me just share my screen. Okay, can you see my screen?
Yes, we can. You have 5
Okay,
minutes, please proceed.
so I'm presenting for group 20, and yeah, so we worked on restaurants revenue prediction, and okay, so these are the group members, including myself, that worked on the project. And I just want to say thank you very much, guys, for your contribution, because okay, so the problem statement, we were given a data set to actually help new upcoming restaurants, or should I say upcoming restaurants rather, predict their revenues based on where they set up their restaurants, right? So we're given, okay, so let me just go with the slides there. So the existing solutions for predicting revenue are using straight line methods, moving average, and also simple linear regression methods. Then, so basically our approach was to, first carry out the exploratory data analysis, checking for missing values and generating different charts to help us gain insight of the data set that we're given. Then we followed that with data pre-processing by doing some principal component analysis, correlation analysis, just to kind of see how the features relate to each other, if one feature has a very high correlation with another, so that we can actually remove those ones that are highly correlated. Then the next part is the modeling. So we had a simple idea of just trying out different regression models, right? So that at the end of the project, we'll be able to say, okay, this is the best model to use for this kind of problem. So basically, we tried out linear regression with lasso regularization, then the same linear regression with ridge regularization, and the XGBoost model. Then, of course, the last part of the project was to build a pipeline to implement the previous step I just talked about. Okay, so for the description of the data, we had a training data set with just 137 observations, which in my opinion is actually very small, right? So then of course we also observed that the test data set had 100,000 observations. So some of the features of the data set are the ID, the opening dates, city and city group, restaurant type. Then we have some obfuscated data. That's data that we're not really, we didn't really know what they meant, right? But we're just giving that, okay, features P1 to P37 as data of demographic features, commercial features, and real estate features, and something like that. So the data source is actually, okay, so this problem was actually a competition that held like 5 years ago. So we're just like trying to see, if we can build a model out of the data sets. So for data wrangling, during the EDA, we found out that the data had like lots of zero values, right? So, we knew we were dealing with like a sparse kind of table, a sparse matrix rather. And then, yeah, I've talked about the EDA. So the pre-processing, we had to generate like a heat map to see features that were highly correlated. So that like helped guided us in just selecting a particular value for which, if the correlation is more than that value, then we would remove those features from the data. Then we also did principal component analysis. So basically, we had two pre-processing stages. Okay, so these are some of the charts we obtained from the EDA. We have the revenue per restaurant type. So we had 3 restaurant types in the
The time is up,
set.
Oluwaseyi. Please round up in 10 seconds. Please.
Okay, so these are some of the other charts we had. And okay, so the model evaluation, we observed that the XGBoost model under correlation preprocessing actually did better, while in the PCA preprocessing, the lasso and reach actually have, like the same level.
Thank you. Thank you, Oluwaseyi. Sorry to cut you.
This is what our pipeline looks like. And
thank you. Thank you. Our judges, please.
Yes. Yeah, sorry we had to like cut you short, but it's a good presentation. Can you flip back to where you had the Qflow pipeline? Did you actually do that for real, or is it you built the pipeline components and everything around that? Hello?
Can you hear me?
Yeah, I can hear you now. Did you actually build all those pipeline components in Qflow?
Yes, we did, sir. So actually what really helped us was the the webinar that Simisola from Marvin Code did about 2 weeks ago. So, that webinar really like exposed a whole lot of things to me personally that made me understand how to, find my way around Qflow. I'm still learning, but it's I think I'm much better than not doing anything about it. So,
do you have the source code for this checked in that I can review somewhere?
Yes, sir. It's in the GitHub repository, so I can forward the link to you maybe after the.
Okay. So, what were the challenges you went through building all these components and all the pipeline? Can you describe the pipeline, what you did,
sure, sir.
How everything worked and how everything got connected together?
Okay, sir. So the first step was to create a persistent volume, right? Because since Qflow runs on top of Kubernetes, and these technologies make use of containers, right? So containers are ephemeral in the sense that, a container can just go off at any point on its own. So the purpose of this volume is to create like a persistent storage so that even if any container goes over along the line, we can always go back to that volume to get the data we need. you know, for the other components. So the next component I created was the get data component. So the purpose of that component is just to, you know, get data from a remote URL, right? So what I did before was to just put the URL of the of cargo in the component, but I found out that that URL actually changes, I think daily or something. So I have to download the data itself to a storage bucket on GCP. So there's a URL in this component that links to my storage bucket. So each time I run this pipeline, it gets the data from that URL.
Just one question. So what image, I mean, what's the Docker image you used in that component? You there?
Hello, sir.
Yeah, what container did you use to like get the data?
Yes, so I used just a Python-based image, Python 3.7 based image, because I was trying to look for, you know, maybe any other lightweight based image or something, but I couldn't really find one. So I just felt, okay, let me just use a Python 3.7 based image.
And what command did you run to get the data sets?
I used the wget command. It's actually a bash command. So, you know, there's this sub-process library in Python that actually helps you run bash commands within a Python environment. So, you know, under that sub-process, I just used wget, then the URL where I needed to get the data from. Then, yes, sir. Then,
yeah, I'll catch up on, I'll look at the source code and everything. Let me just yield so that we don't tie up with good stuff though. Okay. I'll yield to the other judges, like see what's going on. Ask you other questions. Okay.
So summarize your learnings from the whole exercise.
Okay.
Like, what did you learn that you wouldn't have known if you didn't go through this project? You don't have to show the slide. Like, off the top of your mind, what would you say you learned as an outcome of your analysis?
Okay, so apart from personal learning, like getting to actually build a pipeline, you know, on Kubeflow, the other thing I would say is, well, the data set we had was actually, in my opinion, too small, like I said. So I don't think the results we have now are actually a good representation of, you know, I don't think they capture the actual relationship between the inputs and the revenue that we are trying to predict. Okay. So yes, so that's, but apart from that, you know, like I said, our idea was just to try out different models and see which one actually gives us a very good result.
Okay.
So, yeah.
All right. Well, I like the data set that you used, though. I think, or I like the idea. So, good job.
Okay. Thank you, sir.
Yeah, I don't have any question, but just good job. Okay.
Thanks, sir.
All right. Thank you.
Yeah.
Thank you very much.
If you can just drop the Git URL to the source code, that'll be helpful whenever you have a chance.
Okay, I'll do that, sir.
Yeah, thank you.
Okay, thank you. Move on to the next group. That's group 19, electric power, and they'll be represented by Joe Brands, Oladipupo. Sorry, Joe Brands, Iwebu, and Tolu Olorunishola. Joe Brands and Tolu, you have 5 minutes. So let's get this rolling.
can hear me. Hello, can you hear me? Hello?
Yes, we can. Yes,
All
we
right,
can hear you.
can you see the screen? Trying to share. Can you?
We can see your screen, but you're not sharing anything yet.
Okay. All right. All right. You should see it by now. Am I right?
Yeah, good.
Can you?
Yes, we can.
All right. All right. Good afternoon, panel of judges. Good afternoon, everybody. This is group 19, and that's the topic of the project we worked on. That's a household electric power consumption. And well, very quickly, these are the contributors that worked on the project. They are just somewhere watching what is going on. Then we look at the fact that electric load forecasting plays a vital role in overall operation and planning of power systems. And accurately forecasting these demands, helps the power system to work efficiently and effectively. So we looked at the problem. Okay, there's a constant rise in electricity demand. It's not just a thing that happens in a particular place, it's a global thing. I mean, it happens due to things like increase in population and also development. All right, so economic development. So the challenge has been to accurately analyze and forecast the future demands for energy consumption in households. Right. So we started asking ourselves, are there existing solutions? We said, well, maybe there is, maybe there is not. But we just checked out and came up with maybe a few that we think that we could share here. So we have something like energy sufficiency policy, which basically is just about providing energy or supplying based on needs, not actually wants. We need to start differentiating between needs and wants. And of course, look at some hybrid technology, which involves having different sources of energy that complement themselves. Okay, and of course, there are other products that are available, something like SAS energy forecasting and soft energy demand forecasting products. So those things are there helping to actually predict the usage of energy consumption. Now, for the energy sufficiency policy, for instance, if you look at countries like Spain, they were able to come up with a policy that a household or consumers must install smart meters and also house energy management solutions just to help monitor usage and provide a better forecast. Now, approach. We first of all say we're going to frame this as a regression problem, and also wanted to look at this in two ways. It's okay, we're going to look at it as a multivariate data time series problem and also as a univariate time series modeling problem. So we look at both approaches in dealing with this. So of course, when we're looking at it as a univariate time series modeling approach or a problem, we focus on the global active power variable. Now, the data set is a household power consumption data set is a multivariate data set. Okay, that describes the measurement of electric power consumption in one single household over a period of 4 years, okay, between December 2006 to November 2010. Now, of course, I have about 7 different variables besides time and date, and they are the active global power, global intensity, then submeter 1, submeter 3. Then it just says the file is USC machine learning repository, about 20 megabyte size, is a zip file. So what we did was to download and unzip the file where we saw and made use of a TXT file. All right, now what did we do? We wanted to prepare the data, load and prepare the data. So first of all, how to load it into, we use the pandas with underscore CLD function to read in the file, okay? Then also we check for missing values, okay? And we have to mark them with NaN values, okay? That is what we did. Now, because we used two approaches, we for one, when we worked we took it as a multivariate time series problem, we decided to fill the missing values with none. With mean. Okay, but when we were working with a univariate time series problem, we decided to actually remove the missing values. Why? Because the actual is small. It's about 1.2% of the entire data set. So now we say, okay, let's even look at what the data looks like. Let's visually look at it. So because this helps us to look at trends, patterns, or whatever we can get out of it. And that is what we're able to look at in our exploratory analysis. Then we further went ahead to decompose the data into different components, because we're trying to see patterns, whatever we can pick out of there. Now, we went into, okay, one model is, okay, what can we use? So very quickly,
the time is up, Joe Brand. Please round up in 10 seconds.
Okay. All right. So linear regression, ARIMA model, and LSTM. So LSTM is a recurrent where we actually focus. So this is it? Is it what?
It's
can
much.
Hello? So I can hear you.
It's fine. Thank you. Thank you.
Sorry, I can't hear you.
Thank you. Oh. Thank you. Let's move on to the judges. We don't have the time. The time is up. Thank you. Yes, our judges, please.
How did you split the data? Can you hear me?
Yes, I can hear you now.
How did you guys split the data?
Yeah, we did that 80% training set and 20% test set.
Was it random splitting?
No, it wasn't.
So what kind of splitting was it?
Because for the multivariate approach we use, we did with that. It was a random that. But we found out that for time series problems, we had to look at how we can actually split this such that we will be able to work with the data very well. And of course, the guy that did this is actually not handy. I don't think he's available, but that's what we did.
Okay.
I wish I had the source code that would have shown it. Sorry.
Yeah. Can you talk a little bit more to the model approach you finally selected? You talked about linear regression, which I think when you're dealing with the time series data, so that might be a little bit tough to like model with linear regression. And you talked about ARIMA and LSTM. So which model did you go with finally? And can you talk about each, the advantages and the shortcomings?
All right. Now for the linear regression, we didn't actually trust the accuracy we were getting because we just decided to try it. And of course, we had to split it normally, which we believe that was not even the right way to do it, but we're trying out things since we're experimenting something. But for the ARIMA model, which stands for Autoregressive Integrated Moving Average, we also tried to see what we can do with that. And we're able to get some level of results. But due to researches and whatever we've heard or we've seen, through researches we've seen, we found out that LSTM seems to be a very good fit for this, because if you look at this, you find out that when we plotted the graph between the actual and the prediction, it was very close. Okay, so it was just very good. So that was why we had to say, okay, LSTM is what we wanted to. We want to go for. In fact, that's what we even want to go for from the onset. So, but we decided to say, okay, let's try other models and see.
Okay. And what's the advantage? Can you talk a little bit about how you implemented the LSTM?
Okay, for the LSTM, what we did was of course, we defined the LSTM model. So we use 100 neurons in the first hidden layer and 1 neuron in the output layer, okay, to predict. Now, of course, the dropout was 20%. Of course, we used Adams, and of course, the loss function was MAE. Of course, the batch size was about 70, or actually 70, and we trained it for about 20 epochs or epoch.
So in LSTM, you can have a multivariate input that has one output, or you can have a single input that has one output.
Yes.
So can you just, I wanted you to delve more into details about the LSTM model. That's what I'm trying to understand.
Okay.
Well,
the LST, okay.
How did you implement it? How did you implement it? Was it with TensorFlow?
Yes, it was with TensorFlow. Yes, it was with TensorFlow.
Okay.
Yes.
Can you share the code right after this as well? I just
yes, we will.
Okay.
Very well, we will, sir.
Okay. All right. Cool. I'll check the code. Don't let me hold you up for too long.
No problem. Thank you.
Okay, thank you.
All right.
Yeah, so we'll move on to the next group as group 05, Bitcoin trading. And our presenters, their presenters are Jolomi Tosonwumi and Averosu Madagwa. So Jolomi, you're up.
Okay. Hello everyone. Can you hear me?
Yes, we can hear you.
All right, let me start sharing my screen right away. Okay, can you see my screen now?
Yes, we can see your screen. You have 5 minutes.
Okay, all right, thank you. All right, so hi everyone. We are O5 Bitcoin Trading Group, and title of our project is Forecasting Bitcoin Prices. So these are team members. I happen to be the project lead, and I also double as a query analyst. That's because, as we all know, the role of the query analyst is not to be rotated. I was initially the query analyst, but in the middle of the project, I had to assume the role of the project lead also. So our problem statements, our aim of the project is to forecast Bitcoin, OHLC, that's open, high, low, and close, and also the BTC volume and the BTC and the volume of the currency, and also the weighted price from September 14th to December 31st. That's because the data set were given ended at September 14th, all the way from 2012. So here are some of the existing solutions. LSTN was used to forecast just the weighted price, and that was the ROMSC score, and SG boost was also used. And the physical profit was used. That's the RMS score. ARIMA model was used, and all solutions, all existing solutions stated in this slide were given by one Adi Amanda. That's a link to his notebook. So our approach is to, first of all, try to forecast using the univariate time series of each of the columns. And then we also carry out correlation and co-indication tests to see if we could use the multivariate approach. Then if our features pass those tests, we use the multivariate approach using the VAR model. VAR is vector to regressive model. We also use LSTM. Then we select the best model for final forecast. And then as our cost validation strategy, we are going to use the work forward validation strategy for our validation set and recursive multi-type strategy for our art sample forecast. So our data set description, the data was provided by Ziglag and his team on Cargo as part of their web scoping project. The data set is a minute sample of 7 features, which are the Bitcoin open, high, low, close, the volume BTC, the volume currency, and the weighted prices from December 31st, 2011 to 14th September. That's a span of 3,179 days. Total observations in data is 4 million plus, 27%, or more than 27% of the data has non-values. Okay, so yeah, so here's our workflow all the way from our data to our forecast. We first of all load in our data, converts the time stamp to date time object, carry out exploratory data analysis, impute, and we sample. Then we try to approach the univariate approach and the multivariate approach. This univariate approach, we forecast each column separately, and then using the ARIMA or SARIMA model as the case may be, Facebook profit and log short-term memory. Therefore, the multivariate approach check for correlation. We use the Johansen co-integration test, the Granger causality test. Then this red arrow is for the multivariate. So we use the vector to regressive model and log short-term memory. We evaluate our models. We take the best model for our final forecast. So these are the trends, the chart of the open, high, low, close, volume BTC currency and weighted prices. We can see that Bitcoin has really increased in its value right from 2012. And here's the correlation heat map. We saw that open, high, low, close, and weighted prices, they have strong correlation with one another. So for our model, because of the high correlation between open, high, low, close, and weighted prices, we group them into one group of multivariate time series. And they also pass the Johansen co-integration test because we were able to find out that through the test that there exists an eigenvector when operated on 5 of them is going to result in a stationary series. And that's the result of the stationary series after co-integrating these 5 models. And this is the ADF results that this is indeed stationary. And then we, because our general aim is to forecast from September 14 to December 31st, that's a span of 109 days. So we then added the last 109 observation of our sample as our validation test. So we trained on the previous data and validated on the last 109, and these are the results for open, high, low, close, and weighted prices respectively. This is the average mean square error and the mean absolute percentage error. So since volume BTC and volume currency didn't show high correlation with OHLC, and they did also pass the co-integration test, we decided to use long short-term memory for them. And so after making them stationary, this is the result of the ADF. So we did VAR model on them also, but the result was poor compared to long short-term memory. So the best model for volume BTC and currency is the LSTM model, and here is the root mean square error and the mean absolute error. So for our result, we were able to obtain Bitcoin data from this website here from September 14th to October 15th, which is last 2 days, guys, on Thursday, yes, to actually see the relationship between our at sample forecast. So this is our at sample forecast outside of our sample from September 14th up to where we are, that is on Thursday. And this is where we compared it with what actually played out. And from this open, you see that our model predicted a bearish market, but the market went bullish. And these are the root mean square error and the mean absolute error. So some of our observations, we observed that.
Your time is up.
Okay,
so wrap up in 10 seconds, please.
All right. So these are some of our observations. Log short-term memory is the best for for volume and that. So some of our challenges are limited time to try other model like VAMA and XGBoost. Our recommendation, we recommend online learning using work forward strategy, and that is it. Thank you very much.
Yeah. Thank you. Thank you very much, Olivia. Over to judges now.
Thanks. Yeah, thanks for the talk. Can you go back a few slides to where you have the results?
Okay. Of the is it the validation result or
the one where you have a lot of the LSTM? Yeah, this one.
Yeah.
So the out of sample forecast versus the actual. I would say next time the Y scale, try to expand it a little bit, right? So it just looks like the results are way off, but actually not way off, because your MAE is around 4 to 5%, which is pretty good. Yeah.
Nice. All right, thank you for that.
Yeah, I think overall it's a good job. No comment from me. But you say your role was query analyst. What does query analyst do?
Query analyst is to relate with Amoye in terms of sending email to them in case is a communication gap between the group and Amoye.
Okay.
Yeah.
Okay, cool.
Yeah. All right, thank you.
Yep, thanks.
Yeah. So let me stop sharing.
Okay, thank you, Jeremy. Yes, so we'll move on to the very next group 01, university admissions. And the presenters for that group is Miki, Namdi, and Jessica Ojo. So Miki and Jessica, your co-host now, you can start your presentation.
Good afternoon.
Good afternoon, Jessica. Welcome.
Yeah, so I'm trying to share my screen. I'm still disabled for sharing screen, sorry.
Can you try again?
Okay. Okay.
Yes, we can see your screen now, so please proceed. 5 minutes.
Good afternoon, ladies and gentlemen, and our panel. One problem faced by students who wish to enter graduate school is matching their profile with the school of their choice requirements and expectations in such a way that they could secure admission into their schools of choice. My name is Jessica Ojo, and I'll be representing Group 1, which worked on the project University Admission. Statistics have shown that that the number of graduate school applicants far exceeds the number of slots available in schools for admission. This makes the selection process very demanding for applicants. Now imagine if there's a way that you as an applicant could estimate the probability of you getting admitted into the schools of your choice. Imagine the amount of time and energy that will be saved if you could focus on schools where you have high chances of admission. That exactly is the purpose of this project. The purpose is to build a model that could help prospective students estimate their chances of getting admitted into the schools of their choice based on their profile. And your profile should include your CGPA, your GRE score, your letter of recommendations, etc., etc. The data set we worked with was a Google data set. The data set we worked with was a Google data set that has about 500 rows and 9 columns. We trained several models by splitting the data sets into 400 and 100 rows, with the first of 400 being
if you enter your room, I want to carry the laptop come out. I will make a studio.
Being the
Jessica, can you hear me?
Hello?
Can you hear me? Yes.
I'm hearing you.
Okay.
You couldn't hear me?
No, go on now. Go on now.
Okay. Okay. Before building the model, like every responsible data scientist, we first performed exploratory data analysis on the data sets, of which we're able to see that all the features had a positive correlation with our target, which was our chance of admit, which gave with our chance of admit. Now, the chance of admit is a probabilistic values ranging from 0 to 1. We set the threshold of 0.72, which is the mean value of the chance of admit, as representing an high chance of getting admission, while anything less than 0.72 would be a low chance of getting admitted. Now, in building the model, we explored various models, various tree models, various regression model. We also did ANN. We also ANN model, where we're able to evaluate the performance of these models on the last 100 entries using the root mean square error as our evaluation criteria. Now, from our exploration, the best performing model is the Bayesian ridge model, which gave the root mean square error of 0.048 on our train set and 0.032 on our test set. However, before we fitted the model, we first performed some pre-processing, such as testing for normality using the QQ plot and Chromorph, and using power transformation to normalize the data set. After we built our model and fitted it, We then created a pipeline that was built on Kubeflow to help preprocess, train, and deploy the model into production. And into production in such a way that when new data comes in, there'll be no need to retrain the data from beginning to end. Rather, we just run it through the pipeline for it to give us a predicted value or a predicted output, which is your chance of admit based on the threshold sets. In summary, this project, if deployed into production, would help a lot of prospective students worldwide in estimating their chances of getting admission into the school of their choice, thereby effectively enabling them to streamline their choices of universities. Now, this project was worked on by 12 members and was completed within the space of 3 weeks. The project is an open source, so it can be further taken by other parties or interested parties for further research and analysis. Thank you for listening.
Thank you so much, Jessica. You were just right on time. So move over to our judges.
Just out of curiosity, do you know why the Bayesian ridge model outperformed other models? Like, do you know why it did better than other models?
Jessica?
Sorry. The Bayesian model did better than other models. Yeah, it did better than other models
Can you
because
go back to where you had a plot of the models that you used?
yes.
Okay. Okay, so yeah, I was just wondering why, because from this model, from this plot, it's showing that your best model is what's the units on the x-axis? What does that stand for?
That's their performances, the root mean square error.
Okay, so that's the lower,
yes.
the lower RMS is much better. Okay.
Exactly. All the models were trained using the same data sets, the same normalized data sets. So they all performed based on their capacities.
Okay. All right, sure. Did you normalize? Did you do anything to your target? Did you normalize or standardize it?
Yes, we normalize using power transformation.
Okay. All right, thanks.
Yes.
And you mentioned that you use Kubeflow at some point.
We used
Kubeflow?
Yes, to create our pipeline.
Okay. Do you have any reference to it that we can check offline?
No, our only reference would be on the project in the GitHub page right now.
Okay. Can you just share it on the Zoom as well? We want to take a look.
Okay. Minutes.
All right. I think that's it for me.
Thanks give me a minute. Let me get it out and share it.
The last question, so that we can have the next speaker.
Yeah, but overall, good job. Yeah, it's good that you're developing work for others to take forward. So.
Thank you very much.
Yeah, thank you.
Okay, thank you, Jessica. Our next group is group 16, hotel reviews. And the presenters are Oluwatosin, Olajide, and Iwozo John. Oluwatosin, Olajide, and John.
Hello.
Yeah, hello, John. We can hear you.
Okay, good afternoon. Let me share my screen right here. Can you see my screen? Can you see my screen?
Yes, we can see your screen now.
Okay.
So you have 5 minutes.
Okay. Good afternoon, everyone. My name is Iwaza John, and our group worked on the data set for hotel reviews. We had about 9 active members in our group. I was the query analyst in our group. Now, for the problem statement, every year thousands of people travel to different locations all over Europe, some for vacation, some for tourism, some for other reasons. And the thing is that they are plagued with the choice of hotel to stay in, because making a wrong choice could result in something else. So now we are trying with the help of our data set, we're trying to build recommender system, that is recommender models that are able to recommend hotels that will suit the customer's description, that will suit them, so that they will be satisfied. So our approach, there were about 6 different stages. First, we downloaded our data, then we did some data cleaning. These stages will be explained in further slides. So we did some data cleaning, we filled our missing values. We also cleaned some punctuation in text. Now we also did some in-depth data exploration and analysis, because it was very useful to gain useful insights. Then we also did some future engineering. That means we created new columns in the data set. We created new columns so that we can use for our modeling. Then we did our data modeling. We actually created 3 different models, and then we did our pipeline deployment. Now this is a graphical representation of the entire workflow. So you can see that from data cleaning, we filled up missing columns, some unnecessary rows were removed, to the exploratory data analysis. Then we did future engineering of the columns. Then we did the model building, then deployment and customer use and now the data set description. The data set was created from Booking.com, an online travel agency. It contains more than 515,000 customer reviews and about 1,492 unique hotel names. And these data sets contain many other different fields, such as review, average score, reviewer score, hotel name, hotel address. So the data set was a very good one to work with. Now, explaining the data cleaning steps further, we can see that I reviewed all missing values. Now, the missing values in the latitude and the longitude columns were carefully searched out. They were missing. There were some missing values in those columns. So we searched them out on Google using the hotel name and address, and they were all filled up. We also removed rows that were not needed. For example, in the review columns, we had rows that had no positive and no negative. And what this meant was that the customer did not give a review, so it was recorded as no positive or no negative. So because we were using the data set for natural language processing, we had to get rid of the no negative and the no positive, because those values were not helpful at all. They also removed punctuation in text. In the tags column, we had to remove it so that we can use that column for modeling. Now, this is an example of the this is some of the exploratory data analysis. Now, in the first graph, you can see that the total hotel distribution. We can see that the hotels are distributed across 6 countries: the UK, Spain, France, Netherlands, Austria, and Italy. And we can see that the number of hotels in the UK surpasses every other state. And we can also see looking at the second graph, we can see the distribution of the average scores of the hotel. We can see that the average scores is within the range of 5.2 to 9.8. And we can see that most hotel were given the average score of 8.4. Now, these are some word cloud visualization of reviews. We have we did so many of this. We explored the data. These are here we can see that the most important positive words. We can see that that's what customers actually puts in the positive reviews column. So what customers did, the words that was popularly used there was location, good staff, friendly, excellent. So we can see that those were the most positive words there. And we can see in the negative words, this they look familiar. People complained about the room, complained about breakfast, complained about little things, complained about Wi-Fi, maybe something is too small, the hotel service and all that. So these were very useful for getting deep insights. Now we can also see we also explored the critical scoring of both citizens and tourists in each country. Looking at it, we can see that UK with UK being the only exception, tourists give higher scores on average because if you look at it now, we can see that these represent tourists and this represent citizens. So we can look at it carefully. But we can see that that UK the citizens the average score is actually a bit lower than that of the tourists. So the data modeling process to then build three different recommender systems based on weighted average, based on reviews, and based on tags and countries. For most of the modeling, we made use of natural language processing tools because we made use of reviews, made use of the tags column. So these were the key ingredients here. Now, for the recommender based on weighted average, this model made use of some future columns from the data set to calculate the weighted average for each hotel and then rank the hotel in descending order and recommend them to users. Now, this was the formula we used where W is equals to RV plus CM over V plus M, where W is the weighted average, V is the number of votes for each hotel. Here we use the total number of reviews column. R is the average rating for each hotel. Here we use the average score column. Then C is the mean score across the average score column. The mean of that column was computed. Then M is the minimum votes required for a hotel to be in the top list. So the average voting was used instead of the reviewer score because we had the reviewer scores column and the average score column. So the average voting was used instead of the reviewer score because human bias was eliminated by increasing the numbers of different unrelated scores. Now, this is an example of the recommender based on weighted average. You can see that if we recommend the top 30 hotels, you can see that this was what we were given using the weighted average. Now, this is also recommenders based on reviews. So this model takes in hotel name as inputs and recommend hotels based on reviews, both positive and negative reviews from more than 515,000 hotel lodgers. So in this model, the positive and the negative reviews were combined and they were vectorized using TF IDF vectorizer from an XKLN future extraction module. So this way we obtained we use similarity scores to obtain cosine similarity to obtain the similarity between these vectorized values. Then the values were then sorted out to output the ranking of the most popular hotel for each, the recommended hotel for each specified hotel. Now, seeing an example here, we can see that when we put hotel arena,
John,
because
your time is up,
yes,
so try and wrap up in 10
okay.
seconds.
So we got similar hotels like this. Then we also did based on tags and countries. This one accepts countries and the description, and it will recommend recommend similar hotels too. Then we also built our pipeline using Kubeflow, and
Thank you, John.
it was
Thank you so
successful.
much. Yes, thank you very much, John. So we'll move over to our judges.
So you basically worked on a recommendation engine.
Yes, sir.
And are you recommending based on a user's historical record, or you're just recommending based on, is the item based recommendation or user item based? So if I've been to like London before and I selected an hotel, are you recommending for me based on that, or based on the kind of hotels I stay in, or you're just recommending? I just want to know
The
how
hotel,
that.
the way the recommender system was that we use recommender system based on reviews that have been given in the past.
Mm-hmm.
We
So
recommend
we
based on use item, not on user item. like based on the item, not the historical data of each of those listing, but based on the data we have.
Okay, so you basically recommend, it's a general recommendation, it's not to my own preference, it's just like, okay, I'm in
Yes.
London. What determines the hotels I see?
But where we're able to like kind of personalize it with the last one, with the tags and countries. With the tags and countries, you could input the country you are going to and whatever you are going to for the country. I think you can go back to that slide. Just like to show
You can
it.
go back to it, yeah.
To the tags and country. Can you say, John?
I can hear you. I'm talking.
Okay.
Use this.
Yeah, with this.
Okay. Yeah, well, I'm trying to see like how do you recommend something based on my preference. So let's say if I normally travel, I stay in a 2-star hotel, and I'm in London. There are like a bunch of hotels in that street I'm in right now. How do you recommend something for me based on my historical travel preference? So you're not keeping a record of, you're just using the rating, the likes of what people say,
Yeah,
and you're
yeah.
recommending.
We're not
We'll talk
recommending
after
based
the
on your
like.
historical data. Like if you check the recommendation, John, please go there. Examples of recommendation.
Yeah.
For the examples of recommendation, you could just input the country you are going and what's the purpose you are going to the country for, whether it's for leisure or for business trip or for whatever.
Okay.
Yeah,
Okay.
this is it. Netherlands, I'm going for a business trip. I need a standard room and I'm staying for 2 nights. It recommends Waldorf Astoria, Amsterdam, and gives the address.
So what if I put in a variable like, okay, this is how much I can afford. Like I'm going to Netherlands. I need a cheap bread and breakfast to stay. I don't want to spend more than $100 or $50.
If you use the keyword cheap, it would get something related to that for you, but an exact amount, we didn't cover that.
Okay. So, but if
It
I
was it
use a
was not
keyword,
given. It was not given in our data.
okay, all right, cool. Good stuff. And you're using the TensorFlow recommender, the new recommender open source project in TensorFlow. What
No,
recommend?
we built everything from ground ourselves.
So you build your own recommendation engine.
Yes, sir.
Okay. And so did you do things? I just want to know a little bit. Can you talk a little bit more about the recommendation engine?
Okay, we have 3 different types. We have one based on the weighted average, where we can use we calculated a rating, and by that we can produce the top 30, top 10, whatever values you ask for. We have another one based on the reviews. We did sentimental analysis to know what the general public feels about that particular hotel, and we kind of used a linear kernel to find the similarity. Then this last one, what we did was basically we grouped each of the hotels by country. Then we took the tags and put them into account. So like in this I'm going to business trip, I need a standard room. What to pick out is business trip, standard room, and 2 nights. Then to recommend hotels based on those keywords.
Well, what if there's no relevant keywords in the sentence? So you're doing kind of like named entity extraction to basically understand the semantics and syntax around the word. So, but what if I'm not like explicit and I'm not giving all those things as indicators? Like I'm doing that, I mean, you can word it in a different way. Is your algorithm still gonna pick it? Because for you to get to that kind of level, which is highly unstructured, um, sometimes if the model sees something that is not the model sees something new that it has not seen before, it's gonna like crap out. So how do you work around those edge conditions?
We haven't been able to test it to that extent, so we
Okay.
can't say for now what to do.
Okay, cool. Yeah, I'll follow up with y'all and see how we can probably test some things around this because we're doing some stuff related to this. So I'm really interested in recommendation engines. All right, cool.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah, I have nothing.
Okay. Okay, so we'll move on to the next group for the presentation. We need to move at a faster pace now because we've gone past our time. So the next group, Audrey, Bello, and Abib Agbaje will be representing group 08 weather condition. Quadri, Bello, and Habib Agbaje, we need to move at a faster pace, like I said before. Please. Quadri and Habib, if you're here, let us know. Okay, just got Quadri's message that he can't unmute.
Okay, sir. Good day, sir.
Good day,
This
Quadri,
is
welcome.
Yes, so I'll share my screen now. Sorry, I'm not allowed to share my screen. So I'm not allowed to share my screen yet. Okay.
Yeah, hold on a minute. So can you try now?
Okay, sir. I'm still disabled, sir.
Quadri, can you just start off telling us about your project while we try to fix it?
Okay, sir.
Thank you.
Okay, sir. Good day, sir. I'm called Bello. I'm good pay to weather condition. Our problem statement. Our project statement is to Our project statement for the project is to build a time series forecast model that will predict the temperature of any given city across a specific period of time. There are many elements that make up both the weather and the climate of a geographical location. The most significant of these elements are temperature, precipitation, and so on. So in this project, what we did is to work on the model and build the pipeline that will forecast the temperature of any given station in a specific period of time. Existing solution to this project is to use a simple invariance forecasting model like AR, and another solution is to use the forecast value for each series individually using the techniques we already know. But our own approach is to use a multivariate forecasting method to understand and use the relationship between several variables that is useful for describing the dynamic behavior of the data and also provide better forecasting results. Our data set description include information on weather conditions recorded on each day at various weather stations across the world. So in this project, we have many columns. Our data handling, processing, and exploration include dropping columns with 80% NAN. We drop minimum mass and mean temperature with the variance because it's similar to the mean temperature, maximum temperature, and mean temperature with the Celsius scale. So and these are our data. We have stations located in different parts of the world, and we want to build a time series forecast model and build the pipeline. So we use three models: the VIR, VECM, and LSTM. We use the LSM. We recommended the LSM because the VAR and the VECM
as task model and cannot be connected to a service pipeline. So we cannot be the pipeline for them. So we work majorly on the LSTM. And our model, we have different stations across the world. So we pick Apapa Lagos, Nigeria to test the model. So in the future, we recommended that we can use a model that will be able to collect the whole data from all of the stations and forecast it. But in our own model, we can only pick a station and forecast for it. So we pick Apapa Lagos, Nigeria, with station number 3001. We drop columns, like we drop the snowfall and the poor weather column, because in Nigeria, we don't witness snowfall and the snowfall is correlated with the poor weather. So we drop the snowfall and poor weather. So we worked on the maximum, minimum, and mean temperature. So what we did is, when we were working on the VR model, we checked for the stationarity. We performed series transformation to remove systematic structure from time series. We check if there's correlation, because in one of the correlation for a VR model to work is that each of the time series in the system must influence each other. And we split our data into training and testing. The evaluation, we evaluate the forecast. We complete a comprehensive set of metrics, namely the MAPE, the ME, MAE, MPE, and the root mean squared error. So we build a machine learning pipeline. The components of our pipeline include data injection, data transformation, model building, model packaging, and model validation. In our recommendation, we recommended that the components there are some important components that can be added in the future, which are the data validation component and the model blending component. So in summary, in this project, we covered VAR, VECM, LSTM from scratch beginning and from the intuition behind this. The model with the best result is VECM, but the MAP that we use, the values are very close. So we did not actually conclude that this is the best, because we can still fine tune it more to increase the model. But for the pipeline purpose, we use the LSTM.
Sorry, Kodri.
Model.
Sorry.
Sir.
1 second. Yes, you can share your screen now. Sorry for that glitch.
Okay, sir. Thank you, sir. So can you see my screen now, sir?
Yes, we can. Yes, we can. So continue from where you were.
Okay. Like I said, the component of our pipeline includes data injection, data transformation, model building, model packaging, model validation, and model validation. For this component, the data injection is all about loading data. The model transformation is for preprocessing and splitting data into train, val, and test. We converted model building and packaging into a model training step. Made the edits in this. And the model is built, compiled, and trained. The validation components get the metric values, RMSE, MAE, mean, mass, and etc. So some important components that could be added in the future include data validation components and data blending components. This is our machine learning pipeline. So in summary, in this project, we covered VAR, VECM, LSTM from scratch beginning, from the intuition behind it, causality test, preparing the data for forecasting. We build the model, we invert the transform for the case of the VAR to get the actual forecast. We plot the results and compute the accuracy metrics, and we also build the model pipeline. Thank you.
Thank you, Kodri. Thank you. Sorry for the glitches that we had, but we have to move at a very fast pace as well. So we'll just listen to the judges in more quickly before we move on. Thank you.
What's your average MAPE? I don't know if you mentioned it. Like, what was your best MAPE actually?
Our best MAP is the one for the VECM.
Can you go to the slide?
It's not in the slide. It's not included in the slide because our project statement is that we want to build a model pipeline, because we cannot use the VSM to build a model pipeline because it starts model. So we focus more on the LSTM.
Okay. Sure. Thanks.
Okay, thanks.
I think on my part, I'll just hold off. Can I get a copy of the slide? I think that would help, or maybe a follow-up to present this again, then I'll follow up with some questions. Because I couldn't see your slide all through, so that was really helpful.
Same here. You can share the slide with us. Yeah, I don't have any other comments.
All right, sir. Thanks, sir.
All right, thank you. Thank you. So we'll proceed immediately with the next group, 03 presidential elections. And the presenters are Oreka Precious and Tuareg Aruna. Please, you have 5 minutes and we need to move at fast pace, so the time starts now.
Hello, can you hear me?
Yes, we can hear you, Precious.
Okay, I'll be sharing my slide very soon.
Okay.
Sorry, can you see it?
Yes, we can. Please proceed.
Okay, good evening, everybody. My name is Precious Oreka, and I'll be presenting with my colleague, Tuareg Haruna. Yeah, we have the team members who were active during the process of the project. Okay. To begin, it is undoubtedly true that even with the presence of institutions and services of the safety personnel, healthcare workers, e-commerce, entertainment industries, if there is no good government to ensure the proper management of these institutions and executive effect policies, its effects will not be felt by the populace. Hence, there is a need for good and efficient government in the society. And that being said, our project focuses on finding trends and patterns in the US presidential election ranging between 1976 to 2016. We are also trying to determine the total number of votes for each candidate in all states between 1976 and also the total votes between that time range. And most importantly, we are trying to predict the likely winner for the next presidential election. Our approach. And we made use of two different data sets, which were data specific to presidential elections, and we treated each data set separately. Talking about the presidential election, we made use of a classification model. This was our main data set that we focused with. And in this data set, we discovered that for years, years back, we discovered that parties like Democrats and Republicans, which are the two major parties in the United States, they had these trends. So we got insights from it. And what was this trend? We discovered that during this trend, they had about 6 states. For the Democrats, they've won consecutively 6 times in a row over 18 states, and for the Republicans, they've constantly won over 13 states. So these were trends we're trying to get patterns from so as to predict our next presidential elections. Then talking about the presidential election by county, we were limited with the main data set because it has just very few features to work with. So with this data sets, presidential election by county, we're able to draw insights from important features such as the poverty rate, occupation, Black Americans, the earnings, the GDP ratio of the country, and the educational background of the candidates. So we discovered that there was a change of opinions between 2012 election and 2016 election. We can recall that 2012 election was where the Democrats, Barack Obama, won, and 2016, which is still ongoing, is when the Republicans won. So from this, we're able to ask ourselves questions like, this change in opinions, like why would this affect the next presidential election? So we took insights from those factors I mentioned earlier, like poverty rate and the rest of them. So we made use of feature engineering to select the most important data set that we needed for our project. For the data description, like we can see for the data description, it contains total number of votes from each county, population of citizens according to their races, white, Africans, Americans. We discovered that for the races, especially Black Americans, they were not so okay with the Republicans being the last presidential candidate was Barack Obama, and he was a Black candidate. So we looked for how these small changes, such as poverty rate, affected the decision making or the opinions of those voters. So the model we used, we made use of, for the presidential election by county, we made use of a logistic regression which was a multi-output regression model. Our findings here were we made use of Democrats 2016 and also Republicans. So we're trying to understand our models here to know how we can correlate it with the main data set, which was the data set presidential election between 1976 to 2016. So from this data set, using our multi-output regression model, we had an R-square value of above 97%, which tells us that our model actually fitted right into the results, the test set. So we eventually decided on using the XGB classifiers for our main data set. And in this data set, we carried out random forest classifiers, carried out XGB classifiers, XGB RF classifiers, and we got values, accuracy values of above 97% and precision and recall scores, which were very, very high. So that tells us that our model was very good to carry out predictions. So this is just a pictorial representation of the election results of 2016, where we were able to accurately predict that the Republicans won massively, comparing between the two major parties, which was the Republicans and the Democrats. We were not able to show so much images because of trying to beat up with time. Then our model pipeline, we carried out pre-processing of the data, we trained our model, we tested the model, and we carried out deployments of the model.
Precious, the time is up, so please round up in 10 seconds.
Okay, so this is just the pictorial image of our modern pipeline. And in summary, I would say based on insights from our data, we're able to follow up with trends, come up with findings from previous election results that were important in our decision making. So for our model, we were able to establish the winner of the presidential elections. And with this model, we can comfortably make accurate predictions for future elections.
Yes, thank you. Thank you. Thank you. So we're running out of time. So thank you. Our judges.
Who's going to win the election next month from your model? Who's not there?
Precious.
Okay, I said the Democrats. I'm no fan of either of them, but from the current trends we followed, they have this open voting system and the votes have been going towards Democrats. But there is an analysis we read where they said during the voting day, which is November 2nd, more candidates are going to come out. But generally, the Democrats are going to win.
Based on your model?
Okay.
Is that based on your model or?
That was based on the insights we got from our previous results, and our model was actually accurate to predict previous results.
So, I mean, will your model be able to predict margin of victory? Like, is it going to be a blowout? Is it going to be like even split or like narrow win?
It's going to be a narrow. Yes, we can. It's going to be a narrow win actually. It's going to be a narrow win actually.
Okay. All right. Maybe we should come back and judge you after the election and not right now.
Exactly.
Yeah.
Oh, good job and great topic.
Yeah.
You can become, so here's what I'll do. And I think I want to put this feedback because I know we've already run out of time. If I were you, I'll create a blog and I'll put my predictions in there so you can become popular after the election.
Exactly.
Yeah, we had that in mind actually. Thank you very much, sir.
Okay, thank you, Precious. Thank you, our judges. Move on straight to the next group, and then we are just a few groups away from the end of this program. So, police shooting, Group 04, police shooting, and now the presenters are Sharon Ibeji and Fortune Chukwu. Sharon and Fortune. Yes, we don't have time anymore.
Okay, ma'am. Yes, ma'am. Thank you, ma'am.
Sharon, please go ahead. Your co-host now. Okay, if you don't start to the next, okay. Good.
I'm sorry, my network was a bit slow.
Okay, Sharon, we can see your screen now. So please proceed. 5 minutes.
Okay,
Right?
hi.
Fortune, are you here?
Yes, I am. Good afternoon, sirs. My name is Fortune Chuku, and presenting with me is Sharon Ibeji, and we will be presenting on Sharon the first slide. Sorry, we're presenting on an analysis on police shootings to predict on the unjustified shots. And my teammates are here on the call as well. So the motivation for this was to conduct an analysis of police shootings, police shooting incidents in America from the period of 2015 to 2020, to categorize the cases of police brutality towards American citizens. And this was in a bid to help victims that whose family members had died to police shootings to seek justice. And this is because in recent years, in America, there have been numerous cases involving police shootings, and majority of these cases, the police officers go unpunished. So the data set contained information about people, such as their information, their age, their gender, and their race, and also information about when they were shot, if they had any mental state, and if they pose any threats. Also, the objective then was to develop a model that could be relied upon, and we classified cases of unjust shootings using a probability threshold of 60%. Now, what this meant was that cases with probabilities equal to or higher than 60% were most likely unjust. So we conducted an exploratory data set to be able to get insights from our data. And this showed that 63% of citizens or people that were shot were not fleeing, whereas 17% were on car and 13% were on foot. And then 20% had the most years of killings, and then that's reduced gradually. And then also, what was interesting as well was that the threat level, 65% of people that were shot were attacking the officers. So at this point, I'll let Sharon now talk about the approach and then the results. Sharon.
Thank you, Fortune. So before we went ahead to build a model, we intuitively came up with an assumption that can help us develop our target variable. So we assumed that when a suspect did not run nor attempt to attack, there's no reason why the person should be killed, because the person should have been under an arrest. So we had a target variable that was imbalanced with this number of just cases and this number of unjust cases. After splitting our model with a test size of 0.15, we applied smooth to oversample our imbalanced data on the training set. Now, to go ahead with our model building, we worked with 3 models: the logistic regression, KNN, and random forest. Random forest had a perfect accuracy of 1.0. KNN.
Hello? Sorry for interrupting you. Are you sharing any screen, or because I only see something saying conclusion? I'm not sure you're sharing any screen.
Sorry, what did you say?
Are you sharing your screen with us? The slide you're talking through?
Yes, I am.
I don't think I have it.
Yes, I am.
Oh, could it be just me? The only thing
Maybe
I see
network is slow.
Okay.
Okay,
Yeah, it's showing.
can you see it now?
No, not right here.
Okay, just a minute, please. Let me fix that.
No, you can go ahead. Just send the slide right after.
Okay, all right. Can you see it now?
Yes.
Okay.
Yes, we can. Yes, we can.
All right. So we worked with three models: the logistic regression, KNN, and random forest. Random had a perfect model accuracy of 1.0, which felt like there was a bug in the model. And then KNN was it couldn't differentiate between either of the classes, so it gave an accuracy of 0.5 RUC score. And then logistic was a very good model because it could properly distinguish between each of the classes with an accuracy of 0.94. So going ahead, we made use of logistic regression, and then the model predicted 213 cases as unjust, whereas initially we had an unjust class label of 177 out of 735 test samples, using a probability threshold of 60%. So here are some of the sample predictions our model did. So from this, we can tell that these are the cases that were unjust, which can go ahead and file a case against the police or whoever that was responsible for the shooting on that day. Out of our test prediction, we started to find out if there are some similar patterns, and we visualized test shooting rates relating to different races, and we came to realize that there's a low margin between blacks and whites, considering the fact that this data is US-based and whites are more populated. So we assumed that blacks and Hispanics were most likely killed in unjust manners. So some of our limitations during the course of this project were that the data set was full of categorical variables. Because of that, we had to do a lot of categorical encodings, and this included the linearity in the data set. In addition to that, the data size was small, and it affected.
Round up.
Okay, and affected the models we're using. We had to use a simple model. In conclusion, the logistic model was very good to distinguish between each of the classes using a cutoff of 0.6%. So therefore, this model can be deployed and applied to similar cases to predict probability of unjust police shootings. Thank you very much.
Thank you, Sharon. Our judges now.
Did you check feature importance? Did you try to see if there's any explainability for your model?
Yeah, we did. We tried to check if there's some multicollinearity between the data sets, and it was just, we had two columns, the armed and the arms category, so they were highly correlated, and we had to drop one. Aside that, it didn't really change much in the model performance.
Yeah, okay.
Okay, thank you, Sharon.
You're welcome.
So we have just two more groups to go. Please, we urge that you be quick as possible. So group 13, school progress.
Can I give additional feedback for Sharon's Sharon's presentation, that their group? So
yes, please.
With regard to your data, was your data was it specific to a certain region? Like, what part of the US did you get the data from? Was it the southern part? Was it the northern part of the US?
No, it wasn't. It was generally US data, but we had a small sample of 4,000, I guess.
Okay. Okay. All right. I'll love to see what that data is and take a closer look at it, because there are cases of police brutality everywhere, and some of the shootings are attributed to certain areas than they are to others. So it'd be nice to see how applicable or relevant your data is with regards to regions. So, or your modeling and analysis.
Yeah, we visualized that as well. Sorry, it's not on the slide, but Los Angeles was the one that had the highest police shooting rates in our plots.
I see. All right. Well, good job overall. These are very valid topics that you are covering.
Thank you very much.
Thank you, Sharon. Okay, so group 13, school progress, and the presenters are Ulukola Timi David and Ebuka Maria. Yes, David, you can see your screen, so please proceed, 5 minutes. Thank you. David, we cannot hear you if you're speaking.
All right. Can you hear me now?
Yes, yes, we can.
All right, so the problem description is to explore the data sets of Indian schools and to find out the reasons why and dropout ratios and their gross enrollment. So the data set we have a total of 7 data sets, which consisted of information such as dropout ratio. And we have the student categories, they are primary school students, upper primary, secondary, higher, and these are the data sets we have. We have 7 data sets. So I'm trying to be faster. So the Indian school education data set. So as I've said before, the study is inspired to study by the quest to know how Indian and schools are progressing. And these are the baseline questions that we'll be answering here because there's a lot of exploration on the GitHub repo which I will link to, which you can have. There are detailed markdown files there. So there are 4 baseline questions here. Which states have the highest dropout ratio? And those are the questions. So these are the answers, the insights. So the Indian government should look into schools in Nagaland state. If you know Indian state, you should know the Nagaland state. As it was the state with the highest dropout ratios in the data sets we have here have 3 years, 2012 to 3 sessions rather, 2012 to 2015 to 16 session. So the highest average was Nagaland state had the highest dropout. And for the toilet facilities, that's the second baseline question. The government should look into secondary school students because they really had poor facilities. Like I remember seeing very terrible. No, I'll show you a graph here. So they had terrible. I'm not say terrible, but they had poor facilities for toilets. And the gross enrollment for boys and girls were poorest in secondary school, probably because of dropout rate and everything. But while primary students had encouraging gross enrollment, while the last baseline question here was the student category that had the least average of enrollment. And over the years, it actually increased, but only slightly. And that's the secondary school, higher secondary school rather. So this is the graph. So this is dropout ratio. And then the Chegaland, I don't know how to pronounce it, sorry. The Chegaland has the lowest dropout ratio, while Nagaland, as you can see here, has the highest. I hope I'm still on time. The secondary school only, see how poor it is, toilet facilities. This is the average, so you know that it's covering the states, 37 states that we have. And the primary school, they enjoyed a lot, so you can see all of them. And this is for the gross enrollment. This is how the gross enrollment was over 37 states and likewise. And this is for the secondary, higher secondary, so the one that had the least gross enrollment, and it's slightly over the years from 2013 to 2014 to 2015. It's only increased slightly, so that was the business question, so we have to answer. So that's our approach to taking this question as a machine learning problem. It asks to use machine learning to forecast gross enrollment in 2015, 2016, using the data the previous 2 sessions. So from 2012, the reason why 2012 is included is because dropout ratio was not given for 2015 because you are getting data from dropout that was the last session. So you cannot have 2015 data in 2015, 2016 data. I also can understand because you drop out. So these are the steps: join data set, pre-processed, and k-fold validation. The model we used was a simple random forest classifier and a 9 k-fold cross validation to avoid overfitting and to ensure generalization. The model was fitted on 2012 to 2015 session, and inference was made on 2015-2016 session. We decided to use the cross element of students as a target feature since we didn't really have any, but you just from that question, so we wanted to know the gross element, like the type of the states and like the 7 states, how to differentiate them, and we differentiated into 2 groups. We set the threshold of the 58th percentile. So
And this, when we evaluated the model, we had a log loss of mean log loss of this. The mean log loss, the reason why it's mean here is because this is the graph here. So we didn't just make everything. We didn't just make everything like we have one model for everything, because that would not make any sense. Predicting having data for primary students in secondary as there were different
David,
people. Yeah.
Time is up. The time is up. So use 10 seconds. Thank you.
All right, so I'm almost done already. So this is to translate the problem as a regression task. We had the mean square error of 6.38. The summary, this is the measurement state at the poorest stress facility. The improvement that can be made, these are the challenges that we faced, and as you can see. And thank you for listening. I hope I'm welcome.
Yes, thank you, David. Thank you, David. Our judges. Oh. Okay, so if there are no questions, we can proceed to the next. The final group, maybe get more in the recommendations that they'll make at the end. So the next group, which will be our last for the day, is Group 02, Heart Failure. And our presenters, their presenters will be Joy, Achu, and Osagi Emmanuel.
Okay, good evening, everyone.
Good evening, Joy.
Now. Oops, sorry, I'm sharing the wrong screen.
David, you can stop sharing your screen as well.
Can you see? Can you all see my screen?
Yes, we can now.
Okay.
5 minutes, please.
Okay. Good evening, everyone. My name is Joy. I'm representing Group 2, and I'll be presenting our project on cardiovascular diseases, in particular prediction of death in patients with heart failure. These are my team members. The problem statement: heart failure is a common, costly, and potentially fatal condition event caused by cardiovascular diseases. Statistics from the World Health Organization shows that cardiovascular diseases are the #1 cause of death globally. Existing solutions. Presently, the first approach in management of heart failure is usually behavioral approach, so eating healthy diets, obesity, and exercise to treat the management of obesity, individual healthcare interventions, and then treatment with medications. Our approach would use a predictive model for a potential mortality assessment of patients with heart failure. Our approach to build the model is as follows. The data set was obtained from Cargo and used in the Pandas library. Exploratory data analysis was done and revealed that the data set is biased. Feature engineering showed 7 features of importance. Stratified shuffle data split was done due to the biased nature of the data set. Model selection was based on the no-free lunch theorem. Hyperparameter tuning was done using randomized civil set. The model was trained and tested. Data engineers built the pipeline, and the pipeline build was used to validate the deployed model. The data set description, as I earlier said, our source was Cargo, and data set was put together by David and Giuseppe German. The data set consists of 12 features, although the feature engineering showed that only 7 features were important. The 7 features are serum creatinine, serum sodium, ejection fraction, high blood pressure, creatinine phosphokinase, time, and age. Data preprocessing. Data was converted from CSV file to data frame. There were no missing values. Was visualized using the matplotlib and plotly. Okay, so the pie chart below shows the value count of male versus female. If you look at it, it would show it. You notice the biased nature of the data. While this shows the value count of gender that survived and died, this shows the value count of gender with and without hypertension, which is an important feature. And then this graph shows the death events in patients with hypertension. This shows this graph represents death event for patients based on their serum creatinine and serum sodium levels. These represent the death event for patients based on their ejection fraction. The model deployed was random forest classifier and CADBoost. So this is the confusion matrix for the random forest classifier. From this, we would say that out of the patients that survived, the model predicted 23 correctly and 1 wrongly. And out of the patients that died, which is negative, it predicted 5 correctly. It had an accuracy score of 0.96 and an F1 score of 0.90. For the CADBoost classifier, the model predicted 23 correctly and 1 wrongly for the patient that survived. And out of the patients that died, the model predicted 1 correctly and 4 wrongly. Had an accuracy score of 0.93 and and an F1 score of 0.80. So we could see that both models, the random forest classifier had a higher accuracy score compared to the CADBoost classifier. The pipeline was built by the data engineers, and then it shows the predicted and actual values. In summary, based on the predictive models and the features, we could say that random forest classifier is a model to be deployed when trying to predicting death events in patients with heart failure. The major challenge we faced was lack of adequate collaboration from stakeholders. Thank you.
Thank you so much, Joy. That was presentation. So our judges, next, any comments or questions rather?
Let's stop staring my screen.
Yeah, great presentation. I don't have any comments really, but it was a good presentation.
Okay, thank you. So guys, with this presentation means that we've come to the end of the open source project presentation, but we will not just leave your hand to dry. So we'll leave our judges now to give you a couple of recommendations, advice, and more things that you need to further buttress your data science career. So we'll start with, okay, maybe Biodu can start.
Yeah, absolutely. Let me turn on my video. So this would be a general feedback to everyone. Overall, I thought the presentation was good. I'm very impressed and I feel very positive about the future of Nigeria. I think you guys are doing things that a lot of people aren't doing yet. What I would say though is your presentation focused a lot more on the technical side. And I understand that that's what you guys are working through in the data science program. It's important to start thinking more in the business side as well, because obviously the reason why you're doing this is because you're trying to be successful if we have a data science career. So my recommendation is for every data you analyze, think about the business impact. The business impact cannot be direct. It might be indirect. As an example, police shooting. How can that lead to some form of business impact? If you are able to predict police shooting in specific regions, can you make recommendations to the government? Can you write a blog about it, or your presidential election forecasting or prediction? Can you do a blog about it? Can you make recommendations or become a thought leader? It's always also good to think about how are companies using this type of data. A lot of companies make money using this data by saying that, all right, so here is an additional factor that I can add to the data that would make this prediction swing another direction. So you can then be the thought leader and say, hey, Democrats or Republicans, if you do this, the chances of winning the election become 80%. So think more about the business side of it. I didn't see a lot of business focus in your recommendations, and I think that's something that you all need to think about. Even heart. I mean, if you're able to save someone's life for another 10 years, who knows? Maybe that person can save the world. So how are you able to focus a little bit more on the business side? That's my own general feedback to you all. Other than that, I think you all did well. Coming together as a group is not easy, so keep it up and keep looking for all the projects you've done. Write a blog about it.
Thank you very much, Viedu. I'm sure our participants are quite excited. So, okay, I think Wally is ready.
Yeah, I'll go next. And I think I would probably give some general feedback, and then there are a few things where I have specific feedback. And a lot of the stuff that Biodo mentioned, I think they're very true. The presentations were good. However, you guys focused a lot on the technical part, and if you're working on socially conscious projects, like you're working on things like crime and unemployment, election, things around police shooting. There are a lot of assumptions, a lot of things that just looking at the data doesn't help much better than technical stuff. So I would say try to always focus on understanding the data, understanding the problem statement, and also the sort of business or social value that you can get from the project. I think that's really, really important. In the data science, machine learning world, you go into a boardroom with important stakeholders. I bet you know a lot of them don't even care about what random forest is, right? What you have to just tell them what are your recommendations from what you've done. Another thing also, I asked a few questions around explainability. The idea is that when you're using machine learning for high-risk problems or high-risk solutions like elections, police shootings, and things like that, in some cases, and also because of regulations, you need to make sure that your models are explainable. You can actually interpret, what are the feature importance for every prediction that you're making. What are the factors that would swing the predictions maybe to the left or right or whatever? So that's also very important. In terms of time, I wouldn't say it was obvious, but I feel like a lot of people did not practice the presentation before giving it. It's extremely important to practice and also to be able to time yourself, because when you practice and you try to practice within 5 minutes, you wouldn't get to like maybe the 5th slide out of 10 slides, and then they tell you, oh, it's almost time. So yeah, that's there. And then some presentations are too congested. I feel like for a lot of them, you don't necessarily need to write a lot of words. We're probably not going to read them if they're too much. So I would say, yeah, that's the general feedback. To specific themes, I probably have 3 or 4 here. Road safety. I really think that project should be modeled as a time series project. And also just because there are a lot of seasonality, there are a lot of things going on around, like November and December, you have more accidents. Apparently also, I think I've worked on that UK data set before, and you would see that you actually have much more accident during a certain period of the day than some other period. So those are some of the things where when you're doing time series modeling, you get seasonality, you understand sort of the seasonal variations in the data. Feature importance was not done. And then also you guys dropped features with very little missing data set. I think it should be the other way around. When you have like 80% missing, then you can drop it. If you have like very little and you drop it, the ones that are not missing are going to give you very important signal. So you dropping it might actually affect your output. So that shouldn't be done. For the suicide cases, the exploratory data analysis wasn't properly done. I couldn't understand like the plots. I really think it could get better. And the same thing for crime and unemployment project also. I think the EDA could be done better. But overall, I think good job, guys. Really exciting. Build recommendations that you write a blog about it. That would be exciting. Just try to do it. So that's all I have.
Thank you so much, Wally. I'm sure our participants now are excited. Okay, so Charles.
Yeah. Sure. Overall, I think, like Wally said, this is a good very first step. Most of you probably have not done this before, so this is the first time you're doing it. But at the end of the day, you can wrangle the data, you can build all these things. You need to be able to tell a good story about it. So, like I'll key in on what Wally said, that was very important. If you've practiced it well enough, you'll basically have a timer to yourself that you know, okay, I can just summarize this and make it in like 5 minutes. 5 minutes is a short time for any presentation, but I think you guys should just spend a lot more time fine tuning your craft and making sure you have it all nailed down in that 5 minutes. And some of the presentations were like too many words, like the verbiage were too much. So I think that will easily get people lost, and I got lost occasionally as well. So I think if you're trying to do presentation next time, you just start with like the introduction, you dive right into it, and you have your conclusion. I think that will be very helpful. So overall, it could be better. There are things that we need to like all go back and improve on, but I think I'll say this is it's a general good start for everyone, and just don't try to improve on yourself or whatever you're doing. Don't make this a final. So hopefully we can get to see most of you back on the other side, and we'll see how we take this forward. Thank you.
So special thank you to our judges. And we have a lot of head swelling comments here, but then before then, let's just take a particular question that's directed to Bjorn. Ifeanyi on YouTube is asking you, he said that the whole point of having a large data set is to be able to make predictions. He quoted you actually, and was asking for explanations, like what do you mean exactly? Bjorn, you're mute.
Thanks for pointing that out. Yeah, so if you have a large data set, the whole purpose of you having that large data set is to say, all right, so based on what has happened in the past 5 years, if you're applying some type of machine learning model on it, you can say, this is what will happen. Based on what I've seen, based on the trend, this is what should happen next month and 3 months after. I'll give an example. Most retail companies like Amazon or just think about Walmart. Walmart is one of those large chain stores here. They know when they can predict traffic. They know that when it's Thanksgiving or when it's Christmas, there's a lot of demand for certain products. They can also predict traffic based on people's search query. Are people searching for this data, and what time period are they searching for this data? If they know that there's certain products that are being searched for, and they have that data set, historically, within August, September, people search for mobile phones, as an example. They could decide to then stock up on that specific mobile phones because they know it's already become a trend. That is what I mean by using large data set, historical data to predict what would happen in the future. And you can turn that around any way you want, but that's what I meant.
Thank you very much, Bjorn. I hope Ifeanyi is well. Ifeanyi feels better now. So in a very special way, I want to thank our judges on behalf of the participants and on behalf of the Amway team. We've seen a lot of comments from YouTube and Zoom saying thank you for the unbiased judgments that you've given and for your recommendations. And I'm sure that everybody has seen areas where he or she can improve going forward as a data scientist. We originally agreed that this meeting would not take as much time as it has taken, but our judges have stayed to this very time because they want us to improve and they want us to be better. So thank you very much, Wale Akifande. Thank you, Charles Edetiloya. Thank you, Bjorn Awojobi. And to all our participants, we thank you for preparing, taking out your time to make this day wonderful. I've really enjoyed myself, and many persons have enjoyed themselves as well. So we have a couple of announcements, but we don't want to keep you on the call more than this. But then let's just let you know that going forward, we have programs like this in the future, stage F and subsequent stages, and then we'll get an update as regards the outcome of this presentation as soon as possible. Our judges have computer scores together, so after final collations, we'll make an announcement. So let's keep that news on suspense for now. So from my end and from the entire Amway team, thank you, and we'll see you again another time.
Thanks for having us. Thanks for having us.
All right, thanks very much for having us. And one last thing, guys, tie this back to dreaming. Think about yourself being that thought leader. You created a project, build on that project, make it bigger, write about it, and start dreaming of you presenting this to the governor of a state. And it can happen. It will happen if you dream and you have faith. So yeah, I'm very impressed with what everyone has done. And yeah, also think about why was it easy for you to find data in the US and you're not finding data in Nigeria? Is there a way to start collecting that data? Can you start using Nigerian data? Think about those things. Be that person who does the modeling of data. First, you need to find a way to get the data, but think about all of those. But yeah, this is all very impressive. And thank you all for having us. All right, bye.
Yeah,
thank you so much.